first thing we're going to do is something very simple. I'm going to show you the simplest thing you can do because you already know how to do this. And I'm going to show you how to do it what I call my way, but it's really, lots of people do it this way, but it's not always taught like this. What if I want to convert 2 feet to inches? So everybody here watching this probably knows, now again, we're not going to use English units in physics, but we're just using this as an example. 2 feet, that's about a foot, so that's about 2 feet, right? You all know that there's 12 inches in a foot. So you all know that you're going to take the 2 feet multiplied by the 12 inches and you're going to get 24 inches. So you all know the answer, obviously. What's going to happen is most problems are not going to be this simple. But you notice how we had to take the 2 and multiply it by something. That's the conversion factor, that there's 12 inches in a foot. We had to multiply. That was very easy, very intuitive. You knew to multiply. But sometimes it's going to be difficult for you to know if you multiply by the conversion factor or divide by the conversion factor. You'll see as we go. In this case, you know very, very simply. So let me show you how to do it the simple way. So we know, right, we know the following. We know that 1 foot is 12 inches. So you all know to multiply, right? Now let's set it up the way that I'm going to teach you. I want you to do every unit conversion this way. You start with what you know. You know 2 feet. So you write down 2 feet down. You always start with what you know. You draw a horizontal line under. Just go a certain distance. You can extend it later. And then draw a vertical line right next to the 2 feet. Now over here in the next spot, I have to write down my conversion factor. I know that 1 feet is equal to 12 inches. And I can write this thing down here in 2 ways. Let me write it the wrong way first, and then I'm going to write it the correct way. I can write it as 1 foot equals 12 inches. Okay, I can write that, which means I would basically stop because you'll see why in a second, but we're basically done. But this is actually the wrong way to write it. Why? Because you want to arrange this thing so that you can cancel the units on the top and on the bottom. If the unit is on the top and also on the bottom, you can cancel it. You know how in algebra, if you have like, x times y divided by x times z in algebra. And there's an x on the top and an x on the bottom. You know that you can cancel them because they divide. X divided by x gives you 1. So they kind of disappear. And it becomes x, it becomes y over z, right? Same thing here. If I have feet on top and feet on bottom, they can divide and cancel, which means they're gone. Because don't forget, I don't want to have feet in the answer. I want to have inches. So I want feet to disappear. But here they don't disappear because I put it in the reverse order. I put it in the wrong order. You don't want to write it that way because nothing cancels. So I'm going to erase this. I'm going to write it the correct way. The way that you would say is, here's my conversion factor. I'm going to arrange it like this. 1 feet, same exact thing, is equal to 12 inches. But when I write it this way, I have feet on the top, which literally cancels with feet on the bottom, and I want you to strike through it. So there are no units left in this problem except inches. So because I've canceled the units, what's remaining when I do the calculation will just be inches. So how do you do the calculation? Everything on the top is multiplied, 2 times 12, and then you divide by everything on the bottom. I'm just dividing by 1, so you don't really even have to do it. So 2 times 12 is 24, and the only units remaining is inches. That's the answer. So again, very simple problem because you already knew to multiply by 12. Everybody watching this knows that. But as the problems get harder, you're not going to know exactly if you should multiply or divide. I promise you by the end of this lesson, we'll get to some of those. All you do is arrange the units in such a way that they all cancel, leaving you with the unit that you want. Then you multiply and divide by everything on the bottom. Now that we have the basic idea down, we can crank through some more. What if I want to say 16.5 inches and I want to convert that to feet? So this is going backwards, 16.5 inches. Now most of you know that you're probably going to divide, right? But how would we do it, quote unquote, my way? 16.5 inches. You always start with what you know. You draw a horizontal line and a vertical line. And we also know that 1 feet is 12 inches. We can write it in 2 ways. We want to write it in the following way. 1 feet is 12 inches. So the conversion factor is written top and bottom, and it's written this way because this is the only way that it can cancel, inches with inches. If I flipped it upside down and wrote it the other way, nothing would cancel because it can only cancel if it's top and bottom. And then I wouldn't have any simplification of the units. But when I write it this way, inches cancel, so it's 16.5 times 1, which doesn't change anything, divided by 12. So I'm doing my division by 12, which you probably already knew that you had to do, and you get 1.375 feet. That's the answer. That makes sense. If there's 12 inches in a foot, then if I have more than 12 inches, I should have about roughly more than 1 foot. So that's how you do it for these very simple things. Now, What we're going to do for the rest of this lesson is just do 4 or 5 more examples, maybe 6 more examples of unit conversions, and each time it'll get a slightly more complicated. So here for the first 2, you probably knew which way to do it. But by the end, let me take a look real quick. By the end, yeah, I can guarantee by the end that you will not know how to do it in your head, and you'll pretty much have to have a strategy. This is the best strategy you can learn to do any of these conversions. All right, so let's go to the slightly more complicated one here. Still not very complicated yet, but what if you had 1.35 kilometers, and we're going to convert that to meters? Okay, again, most of you probably know that you're going to roughly what to do here, but if you don't know, how would we solve it? Well, you start out with what you know. You write down 1.35 kilometers. Now, from our previous lesson, we know that there's 1,000 meters in a kilometer. You have to have a conversion factor that goes from the unit you're going from to the unit you're going to. But again, I can write it 2 ways. I can write 1,000 meters is 1 kilometer, or I could say, you know, the other way, 1 kilometer is 1,000 meters, or whatever. I can flip it upside down. But the only way that works is I write 1 kilometer is 1,000 meters, because this is the only way that I cancel kilometers with kilometers, and so I'm left with meters. So it's 1.35 times 1,000 divided by 1. So it's going to be 1,350 meters is the only unit left. And you all know that if you have 1.35 kilometers, it's going to be more than 1,000 meters. All right. So let's go here and change the units just a little bit. What if we have 2.37 milliseconds, which is a really tiny fragment of a second? We want to convert to seconds. This is actually practical. You might have a problem that says a baseball travels to the pitcher in 2.37 milliseconds, and do some calculation. Well, the first thing you have to do is get to seconds before you can do any of the physics. Okay. Now we know from our metric system discussion, we know that 1,000 milliseconds fit inside of 1 second, right? But we have to use that fact to do the unit conversion. So you write down what you know, 2.37 milliseconds. Draw a line, draw another line. Then you have to arrange this conversion factor. There's only one way that it can work: 1 second, 1,000 millisecond. If I flipped it up over, then nothing would cancel, and then I wouldn't be able to do anything. So in this case, milliseconds cancels with milliseconds. And then I take 2.37 times 1, divide by 1,000, and what do you get in your calculator? You get 0.00237 seconds. Okay. And we already learned scientific notation, so you can leave it like this, or you can write it as how? 2.37, putting the decimal here, minus 1, minus 2, minus 3, times 10 to the minus 3 seconds. These two things are exactly the same thing. The 10 to the minus 3 moves the decimal place 1, 2, 3 units to the left, which is what I started with, so 0.00237 seconds. All right. We'll continue to ratchet things up just a little bit. The next section, or the next problem, let's say I want to convert 3.5 inches into centimeters. 3.5 inches to centimeters. So here, we're going from English to metric. And we're not going to do this too much in physics, but it's a valid unit conversion, so we're going to get practice with it. Now, in order to convert this, you have to know how many centimeters fit in an inch, or how many inches fit in a centimeter. You have to know some conversion factor to go back and forth. You would get that from the previous lesson, I gave it to you, but you could also just get it by opening your physics book. Usually in the front, there'll be a table of conversion factors. So to convert this thing, you look that up first, and you will find out that 1 inch is 2.54 centimeters. That's the conversion factor. So we know the following thing. So in order to pull it off, you always write down what you start with in your problem, 3.5 inches, horizontal line, vertical line. Then you have to arrange this conversion factor to cancel. The only way it works is 1 inch on the bottom, 2.54 centimeters on the top, because that's the only way that you get this cancellation. If I flipped it over and put the 2.54 on the bottom, I'd have centimeters. That would not cancel, so I wouldn't be able to do anything. So in order to figure out the answer here, you multiply 3.5 times 2.54, divide by 1, don't forget by that, and you're going to have 8.89 centimeters. Now, it kind of makes sense that if you have 3.5 inches and every inch is about this many centimeters, that you should have more centimeters in the end. That makes logical sense. Okay, so now we are going to get into the realm. I'm actually going to switch boards. I've only got 1, 2, 3. I've only got 4 more of these, okay? But in the next 4, they're designed to slowly increase the complexity of the unit conversion. And by the end, you should see very clearly how this is the most superior way to do these kinds of things. What if I want you to convert 7.2 inches to kilometers? Now here is where it's tricky, because the only unit conversion that I've really given you is that 1 inch is 2.54 centimeters. I haven't given you a conversion factor from inches to kilometers. And even if you open your physics book, you're probably not going to have a table of how many inches are in kilometers. If you knew how many inches were in kilometers, then it would be a single step calculation just like all the other ones. But you probably won't have a conversion factor. But I don't know how many inches are directly into kilometers, but I do know how many inches are converted to centimeters. And because of the metric system, I know how many centimeters are converted to meters. And also because of the metric system, I know how many meters are converted to kilometers. So it's like a chain. I know how to get from inches to centimeters. If I knew how to go from centimeters directly to kilometers, I could, but I usually don't know that either. But I know centimeters to meters, and I know meters to kilometers. So I'm going to kind of walk down this chain. Now, if you were doing this problem manually without this, then you'd have to decide at each step of the way, do I multiply or do I divide by each of these conversion factors? And it would be very confusing. Let me show you how to do it so it's not confusing. Start off with what you know, 7.2 inches. That's what I know, so that's what I write down. I'm going to draw a long line because I'm going to have a bunch of stuff written down here. Okay? Now, I need to inch my way forward, no pun intended, to get towards kilometers. I know that 1 inch is 2.54 centimeters, so I'm going to convert first to centimeters. The only way that I can convert there is to write it like this. 1 inch is 2.54 centimeters. If I flipped it upside down, I would get no cancellation, so it has to be written like this. So inches cancels with inches. If I just stopped the calculation here and multiplied these things, I would get centimeters. But I don't want centimeters, I want kilometers. Now, if I know how to convert centimeters directly to kilometers, of course I could do that, but I don't know how many centimeters, or, well, I could figure it out, but I mean, I don't off the top of my head know how many. But what I do know is centimeters and meters, right? I know that in general, 1 meter is 100 centimeters. I know that from the metric system. And I write it this way instead of upside down. Like I don't want to put 100 centimeters over 1 meter because this is the only way I get to cancel my centimeters. Because centimeters are in top, centimeters are in bottom. So if I stop the calculation now, 7.2 times 2.54 divide by 1 times 1 divide by 100. If I do that, then I'm going to get the answer in meters. That will be how many meters are 7.2 inches. Okay? But I don't want that. I want kilometers. Okay? So I got to go from meters to kilometers. And from the metric system, I know that 1 kilometer is 1,000 meters. And because of that, I cancel top and bottom. If I flip this over accidentally, I wouldn't cancel anything. So it wouldn't be, it wouldn't do anything. So now I had inches, but I eliminated those getting to centimeters. Then I eliminated those getting to meters. Then I eliminated the meters and I ended up in kilometers. So I started with inches and I end up, the only unit left here should be the one you want, which is what I have. So you take 7.2 times 2.54 divide by 1 times 1 divide by 100 times 1 divide by 1,000. Just do it all in your calculator, just the way I outlined it, and what you will get is 0.000183 kilometers, which kind of makes sense because 7.2 inches is a really small distance. It should be a very small value in kilometers. Now, I can use scientific notation if I want because this is a small number and kind of ugly, so I can write 1.83 times 10 to the minus, and I got to go backwards. 1, 2, 3, 4. 10 to the minus 4, and that again is going to be in kilometers. So these are the answers. Same answer. This is exactly the same as this. If the scientific notation throws you off, go back to the last section or the couple sections ago on scientific notation. I explain all of that there as well. So this is the first problem where it will be very difficult for you to do this in your head because sometimes you're multiplying by the conversion factor and sometimes you're dividing by the conversion factor. And it's difficult to know when to do that. But with this way, it's very, very simple. So let's go on to an even more complicated one. What do I want to do next? What is my next one here? All right, let's do a velocity. This is a fun thing. So this is very common in physics. So let's say you want to convert 2.3 miles per hour. That's a typical speed in the English system. But you want to convert it to kilometers per hour. So you might look at this and say, well, this is different. Because before it was meters and converting to meters, but now it's different. It's velocity converting to velocity. But that's where you're wrong. It's not different. It's exactly the same. This method works if you're converting time, if you're converting distance, like meters, if you're converting velocity. It also works if you're converting any unit, like newtons in physics later, or if you're converting in chemistry, you might have moles or temperature or whatever. There's lots of different things, but this system works for anything that has a conversion factor. So how do you do it? You write down what you know. 2.3. Here's how you write 2.3. Notice the unit is a fraction. So the way you write it is miles on top per hour on bottom, and you draw your line. Notice in all the other problems, you just had a single unit on top and there was nothing on the bottom because it was just inches or whatever it was. Here it's miles per hour, so this is a fraction. I have to write it as the unit indicates. Now I want to convert this to this. So the hours part of my unit is already the same, so I don't want to convert anything to do with hours. I don't want to change the hours. I just want to change the kilometer or the miles into kilometers. Now I already know from a previous example the conversion factor between kilometers and miles. And that conversion factor is 1.609 kilometers, or you can look this up in a book, 1 mile on the bottom. And the reason I write it this way is because then miles cancels on the top with miles canceling on the bottom. If I were to flip this over with kilometers on the bottom, nothing would cancel and I wouldn't have anything that I want. But now the only unit left is kilometers on top, hours on bottom. That's what I want. So I'm done. I don't have to do anything more. It's 2.3 times 1.609 divided by 1, which doesn't really change anything. So you're going to have 3.7 kilometers per hour. This is the final answer. Now, a lot of students get tripped up with this because they see this miles per hour and they start thinking, I got to find a conversion factor from miles per hour to kilometers per hour. What's that conversion factor? You don't need to look up those velocity conversion factors. Every unit with a fraction is just a unit on top and a unit on bottom, and you just have to cancel or convert the unit appropriately. In this case, we left hours alone because that's what we wanted in our final answer, and we just worked on the miles. All right, I only have 2 more. Right? Let's do something more challenging. Let's say I'm going to convert 5.2 miles per hour, and I'm going to convert it into something crazy, like meters per second. Now, this one's even more complicated because I need to somehow convert the miles into meters, and also I need to convert the hours into seconds. So I have to work on both sides. And so, again, some students will look at this and say, well, I need to find a conversion factor from miles to hours to meters per second. What is it? You're never going to find one. You don't do it that way. You work on miles to meters, and in this case, hours to seconds, and you do it all in that single thing that I've been telling you to do. You write down what you know, 5.2, and you draw your line. I'm going to make it long because we're going to need a lot of space, and it's miles on top and it's hours on bottom because that's the first unit I start with. And then I just have to inch my way to get to this unit. So first of all, let's just work on the miles. Forget about the hours for now, just work on the miles. From the last problem, we already know that in 1 mile, there's 1.609 kilometers, right? I arrange it that way instead of upside down because I cancel miles with miles. So now, if I were to stop the calculation now and do this times this divided by this, I would have kilometers per hour. But I don't want kilometers per hour, okay? I want to get to meters. But I know how to go from kilometers to meters. I know that. I know that 1 kilometer from the metric system is 1,000 meters. And I arrange it that way instead of upside down because the kilometers have to cancel with the kilometers. So the only units left are meters and hours. So this is meters per hour. So if I do this times this, divide by this, times this, divide by this, I would have meters per hour, which is a weird unit, but I could do that. I could convert to meters per hour. But notice that I'm halfway there because I've got units on the top of meters. That's what I want. Now all I have to do is work on the hours. All right? So The question is, do you know how many seconds are in an hour? Because I need to go from hours to seconds. Well, typically most people don't know how many seconds are in an hour. You could get a calculator, you could multiply and figure it out. I know that you know how to do that. But let me show you how I do that. I don't know how many seconds are in an hour, but what I do know is that 1 hour is 60 minutes. I know that because I use clocks every day, right? And I arrange it this way because hours would cancel on the top and on the bottom. So if I stop the calculation now, 5.2 times 1.609 divided by 1 times 1,000 divided by 1 times 1 divided by 60, what would the units be? Meters per minute. But I don't want meters per minute. I want meters per second. So I'm going to do this one more time. I know how to go from minutes. I know that 1 minute is 60 seconds. And I arrange it this way because minutes cancel. And the only units left I have in my problem are meters and seconds. So meters per second. I've gotten to my final answer. So how do I get it? 5.2 times 1.609, check myself, divided by 1 times 1,000 divided by 1 times 1 divided by 60 times 1 divided by 60. You string it in your calculator just like I've done it, and you get 2.32 meters per second. So 5.2 miles an hour is equal to 2.32 meters per second. Notice I never found a conversion factor that gives me miles an hour directly to meters per second. I inched my way there, working on the top, doing all the small little conversion factors along the way, and on the bottom, all the little small conversion factors along the way to get there. So let's do one that doesn't involve speed, just to give you at least one. This will be the last one. Let's say I'm going to convert the following, and it's going to be a little bit of a weird unit. Let's convert 3.7 kilograms per hour into grams per millisecond. It's a weird unit just for the purpose of something. First of all, to explain to you how to do it, you might wonder, what's kilogram per hour? That isn't a speed. Speed's like meters per second. But this is a mass divided by a time. What does that mean? That could be a unit of what we call mass flow rate. Let's say I'm filling a swimming pool with water. I have a hose, I'm pumping water in the pool. So this would be how many kilograms of water is flowing into the pool per hour. How many kilograms per hour, right? So I'm pumping a big fire hose, 3.7 kilograms per hour. Actually not so big, I guess, more like a garden hose. 3.7 kilograms every hour goes into the pool. But I want to convert that to grams, which is a smaller unit, but per millisecond. That's per tiny little amount of time. How do I convert between these units? Well, first thing you do is you start with what you know. 3.7 is what I know. 3.7, and it's kilograms per hour. Kilograms per hour. Same thing before. I changed kilograms into grams, and then separately I changed hours into milliseconds. The first thing I'm going to do is we're going to work on the kilogram. From the metric system, you know that 1 kilogram, I don't know how many kilograms, well, I do know how many kilograms go directly to grams. I don't know how many hours are directly related to milliseconds. We'll get to that later. 1 kilogram is how many grams? From the metric system, it's 1,000 grams. I arrange the conversion factor that way because I have to cancel kilograms. If I stop do the calculation now, this times this divided by this, I'm going to get grams per hour. But I don't want grams per hour. I want grams per millisecond. But I'm halfway there, so I close this guy off and I work on getting to milliseconds. So I know I start with hours. I don't know how many hours or how many milliseconds are in an hour. I could probably calculate it, but even that's cumbersome. So I just do it, I inch it along. I say 1 hour is 60 minutes. Okay, and I say, okay, that seems to have worked because I canceled the hours and now I have minutes. Okay, great. Then I also know separately that 1 minute is 60 seconds. So that's great because I canceled minutes and I'm left with seconds on the bottom. But I don't want seconds, I want milliseconds. The final thing I know is that 1 second is 1,000 milliseconds. Now you see why all of that conversion factor stuff was so important. Now I've canceled seconds and now I'm left with milliseconds. So every single unit has canceled. The only one left is grams per millisecond. Grams per millisecond. That's what I'm left with. So I'm done. I don't have to do anything further because I'm got to the unit I want. Start with 3.7 times 1,000 divided by 1 times 1 divided by 60 times 1 divided by 60 times 1 divided by 1,000. And what you will get 0.001028. The unit is grams per millisecond. That's how many grams flow through this pipe of water every single millisecond. It's a small number. okay? And so I can leave it like this, or I can write it as scientific notation. 1.028, the numbers, times 10 to the minus 1, 2, 3. Same unit, grams per millisecond. So I can write it either way, 1.028 times 10 to the minus 3 grams per millisecond. Now I guarantee you, if you try to do a problem like this and convert those units without doing it this way and trying to decide at each step of the way, how do I multiply, do I divide? See, sometimes you're multiplying by something and sometimes you're dividing. And in this case, I had to divide 3 times. Then if you don't do it this way, you will eventually get confused on if you should multiply or divide, and you'll just get the wrong unit conversion. And since you're usually converting units at the beginning of every problem, it means the rest of the problem's wrong. If I need to convert to meters per second and I get that wrong, I can't even do the rest of the problem, and so you don't get anything right. So practice this. Please practice this. Do all of these again, get your own problems, convert them, grab a computer or a calculator and check your work, and get very comfortable with this. I am absolutely not kidding around when I tell you it is the most useful thing I've ever learned. Because even when you're doing advanced physics, even when you're doing like quantum mechanics, you're going to have units, and there'll be times when you have to convert between unit systems, and you're not going to remember if you're multiplying or dividing, or what the conversion factor is, or how it would make sense if you should multiply or divide, and so on. But you will remember that you arrange these conversion factors to cancel, and whatever units are left are the ones that you want, and that's what I have to do. The other thing it prevents you from doing is another mistake I've mentioned a couple times. A lot of students will try to find a conversion factor that goes directly from hours to milliseconds, because they think they need that in order to get to the end. I mean, if you had it, it would be great, but you're not going to find that in a book typically. So instead, you inch your way. It's like the game is not to go from A directly to B. The game is to go from A to B to C to D to D, all the way to the answer, but inching your way there, showing your steps, and then you get there. Practice these, do your own, follow me on to the next lesson, and we will continue studying physics step by step. Learn anything at mathandscience.com.